fun. We're going to do some notes together, and then I will show you in this video which problems I want you guys to graph on your own and send me a picture of. So standard form quadratic functions are in this form. Y equals ax squared plus bx plus c. So we've been talking about quadratic functions because they all form a parabola. But what we've been mainly working with is what's called vertex form. So like in the, the Mario Brothers, that like Super Mario, we did the vertex, like y equals, let's say x minus 3 squared plus 5. We know this goes right 3 and up 5, so we know the vertex is at 3, 5. So it's nice when it's in this form because you know where the vertex is, but a lot of times quadratic equations are written in this form, and there's going to be a number in place of A, a number in place of B, a number in place of C. If you would type it into Desmos, you'll see that it forms a parabola just like these two. It's just a different form. So in order for us to graph a formula that's more like this, let me give you an example. Like we could have like y equals 2x squared minus 3x plus 5. That would also be a parabola, but it's not really obvious where the axis of symmetry or the vertex is. Like this one, it's obvious the vertex is at 3, 5. So what an axis of symmetry is kind of like a mirror. So if we have a parabola, the vertex is at the bottom of the parabola or at the top if it's an upside down parabola. The axis of symmetry is always straight up from the vertex. So it's this line right here. It's like if you would fold it in half on that line, it's symmetric on both sides. That's really helpful when you start graphing points. So if you have the vertex, you know it's right on the axis of symmetry. But say I found out maybe what this point is, to save me some time, I can just go across the axis of symmetry and copy that point over here. So it's kind of like a time saver. If I know this point, I can just reflect it over on the other side of the axis of symmetry. So we're going to learn how to do that. So to find the axis of symmetry, using these numbers, A, B, and C, you really don't even use C for this. This is kind of weird, but you take negative B divided by 2 times A. So if I was doing this orange equation, I would make my 3 a positive 3 divided by 2 times 2. So positive 3 divided by 4. That's where my dotted line would be located. So let's go ahead and what you want to do when you do this, that's going to be your answer for your x, and that's going to be your axis of symmetry that you make a dotted line on. To find the vertex, you plug this axis of symmetry back in the function for x. And I'm going to describe all this with 2 example problems here at the bottom. So this first example problem, y equals x squared plus 3x minus 2. We're going to find the axis of symmetry by doing negative b divided by 2 times a. So if there's not a number in front of x squared, it's a 1. It means 1x squared plus 3x minus 2. So this is a, b, c. The first thing I want to have is negative b. This is b, 3. Negative b is negative 3. Divided by 2 times a. That would be 2 times 1. You don't write the x squared, it's just the number 1. 2 times 1 is just 2. Negative 3 divided by 2 is negative 1.5. Okay, this is the fun part. That's where you put the dotted line. We can also say that equals x. So if we go on the x-axis, I know this graph's probably a little bit hard to read, but I'm just going to go over 1.5 on the left, x equals negative 1.5, and I'm going to make my dotted line like this. All right, so find your axis. So you guys can see it's a parabola. It's kind of cut off a little bit, so I'm going to just kind of do that. So there's our parabola. And I'm interested, so this negative 1.5, watch what happens if I type in x equals negative 1.5. It puts the axis of symmetry right there for me in that blue line. So to find the vertex, we would find the point where on the red graph where it hits the axis of symmetry. So look, our vertex is negative 1.5. That's no surprise. But then it also plugs in the y, like it makes the whole answer. It's left negative 1.5 and down negative 4.25. So that's a huge time saver. Negative 1.5, comma, negative 4.25. So I'm just going to kind of estimate that on my graph, down 4.25. Just kind of do your best. So this right here is my vertex. Now I'd like you to include some more points on your graph. We can make an XY chart and plug in some numbers. But remember how Desmos helps us do that? Go to this little wheel, click on chart, and I'm going to pick a couple of these points. These are going to be so close to where I'm already at. I don't really want to use -2, -4. If you guys look on my graph, it's just so close, like this. So I don't think that's, you know, good enough. We need to do a few more points maybe. How about 1, 2, or 0, -2? Let's do 0, -2. So 0, -2 is here, and I could use my line and reflect it on the other side. See how that, like that, I have 7 points. I only needed 5. And the final thing you want to do is draw your parabola. Okay, so our A is -3, and our B is -9, and our C is 10, but we don't really care about that. So axis of symmetry is -B divided by 2 times A. So -9, what do you think that means? -9, that turns into +9. And then we want to do 2 times -3. 2 times A. 2 times -3 is -6. Oh, and what do you know? That's also -1.5. Just kind of weird that that happened. So I'm going to go ahead and graph -1.5 again. Make my axis of symmetry. And see, that's labeled right there, axis of symmetry, -. All right, I went ahead and typed this into Desmos, and you can see that we have the same axis of symmetry as our last one, but this is a skinny graph, and it's upside down, it's negative. So if I click where my blue line, my axis of symmetry, meets my parabola, I can find the vertex, which is -1.5, comma, 16.75. I know that's going to go, and 16.75. There we go. So this is 10. So I'd say 16.75 is about maybe right under that line, right about there. Okay, and then by looking at Desmos, I know 0 is 10. So 0, 10 is right here, and I can reflect that point across. And another point I find from Desmos is 1, -2. So over 1 down 2 is down here. And I can reflect that across the axis of symmetry. Now make sure when you guys draw this, you try to make it look like a parabola and not just like a straight line with a V-shaped graph. You want it to look like a parabola like that. Okay? So problems we're gonna do, and if you don't have this piece of paper, that's okay. What you can do is you can write these numbers down on your piece of paper. So number 13, I'm gonna have you guys do 13. And we will do 14 together right now as a practice. But if you want to write down on a notebook piece of paper, x squared plus 4x minus 5. So if you don't have this piece of paper, no big deal. Just use notebook paper and please write down that. That's one of your homeworks. We're going to do this together. I think it'd be good to practice that with me right now. X squared plus 6x plus 2. And then let's also do number 16 as your homework. That says x squared minus 6x plus 2. Let's write that down, please. Okay, and how about number 29? 2x squared minus 8x plus 10, and 30. -3x squared minus 6x minus 7. So those are you have 4 questions to graph for homework, but I'm going to do 14 with us together so you know what's needed in order for you to get credit on this assignment. So the first thing I want us to do is like what we've been doing is find the axis of symmetry. I know it doesn't say that right here, but that's going to be our first step. Axis of symmetry. -b divided by 2a. So remember, if there's not a number with x squared, it's 1x squared. That's your A. 6 is your B. 2 is your C. We're not going to use c though. We're just going to do negative b divided by 2a. So negative b would be negative 6, a, b, c, negative b, negative 6 divided by 2 times a. 2 times 1 is 2, and that equals negative 3. You guys remember that's your axis of symmetry. You go to the x equals negative 3, and you go ahead and draw that dotted line. So I need to see your work for axis of symmetry, your dotted line. Okay, now we're going to find the vertex, and if you want to type it into Desmos, you totally can type that into Desmos to find the vertex. You can also take this number and plug it in for x. Okay, I'm just going to kind of do that in my head so I don't have to type into Desmos. So negative 3 squared plus 6 times negative 3 plus 2. So that'd be positive 9 minus 18 plus 2. That'd be negative 9 plus 2, which is negative 7. So our vertex is the negative 3. You take your axis of symmetry. We know it's on this line, comma, negative 7. And again, you can use Desmos for help. Negative 3, negative 7. That point is the first one you always want to find. Okay? Then what I want you to do is find at least 2 more points. If you want to look at Desmos, you can. We also can remember how a parabola with a 1 in front grows, over 1, up 1. And do you remember when you go over 2, 2 squared is 4. And over 3, 3 squared is 9. That's a quick way to do that. Now let's reflect on the other side of our axis of symmetry. That's 1 space from the dashed line. This is 2 spaces from the dashed line. This is 3 spaces from the dashed line. And if you don't have graph paper, just do your best. And there we go. So that's what I need to see. The axis of symmetry work, the axis of symmetry dotted, the vertex labeled here, and then the fourth thing I need is more points, and you draw your parabola. Hopefully that makes sense. I'm also going to do one from, let's see, I'll do this one with you. All right, so see if you could kind of get this one started and think about negative b divided by 2 times a. A, B, C. 8, negative 8, divided by 2 times negative 2, negative 4. Negative 8 divided by negative 4 is positive 2. Do you guys remember what we do with that number? That's your axis of symmetry. So we know that that dotted line is going to be on our graph. That's step 1. And step 2 is labeling your dotted line. Step 3 is finding the vertex. We know that the vertex is going to be somewhere on this line. Oh, it's 2, not 1. Okay, I saw that one there. So it's 2, right? So we know it's going to be somewhere on this dotted line. And so we know the x-axis, or the x-coordinate is positive 2 something. Again, you can type this into Desmos and see where it hits 2 what. Okay, so I'm going to do negative 2, and I know 2 squared is 4, plus 8 times 2 is 16, minus 8. Negative 8 plus 16 minus 8. Ooh, that's 0. Negative 2, 0. Or positive 2, 0. So there is our vertex. Okay, now notice our leading coefficient is negative 2. Do you guys remember it makes it a frowny parabola, and you go 2 times more than normal. So instead of over 1, up 1, you do the opposite. You'd multiply that by negative 2. Instead of over 1, up 1, you go over 1, down 2. And you can reflect that point across the axis of symmetry. Normally you go over 2, up 4. Instead of up 4, you're going to go down 8. Over 2, down 8. And I can reflect that across my axis of symmetry. And so now I have my vertex labeled, and then I have 4 other points, and I drew my parabola. So you have 4 problems to take a picture of and send me for your assignment 1 this week.